Hello students, today we are going to learn about the third lecture, and I hope I hope you all did the exercise that I gave to you. Did you do that? So can anyone did? You can show it to me. Did you work on those exercises? Anyone? So after you work on your exercises, you can take a photograph or a screenshot on your device and you can send it to me. So that way we can learn more things, right? So we will get into the lecture. So we'll go to the lecture, right? So draw the schematic diagram for the following figure. And how will you connect the circuit diagram by using breadboard? So these are the two examples that we saw in our previous lecture. So I gave it to you. So hope you did this. So if you don't do this, it's very simple, right? I can do this. So this is a circuit, right? So we have a switch here, a battery is connected to the switch, and then we have a line, and after it has connected to the resistor, then after it is connected to the LED bulb, then it is grounded, right? So this is how the system is connected. So you all know about how a breadboard will look like, right? So for the new students, I want to recall it, right? So for the new people, I have to recall it. So basically, this is called as a breadboard. So in the breadboard, these lines are connected horizontally, right? And also this line is also connected horizontally, right? Inside it. And similarly, this line is also connected. This line is also connected up to here, right? So in the middle part, each and every line is connected like this way, right? This way, each and every dots are connected inside the breadboard, right? So that is I show in previous lecture, right? So let's get back to the example, right? So how can we draw a schematic diagram for this figure? So it is very simple, right? So you can draw this diagram as like this. So this is the diagram that I expect you to draw, right? So basically I can explain this. So it is very simple, okay? Because we have a battery here, right? So we have a battery here, and then the battery is connected to the switch, right? So you can also put a switch like this, right? So if you don't consider the switch, you don't have to put, right? So you can draw a switch like here, and then you can draw the diagram like here, and then you can connect, right? So this diagram is coming, so these lines are connected, and this resistor is coming from this line. So this resistor is the wire is connected to this resistor. So that is it means, right? It means this line, this wire is connected to this resistor, right? So this is how a resistor is connected. On the other side of the resistor, these lines are connected in the breadboard, right? So we know that. So that we have connected LED bulb positive terminal, right? So this is positive terminal and this is negative terminal, right? So we have connected this bulb and then we are grounded, right? So these things you can know. I will show you how a breadboard will look like in a video for the new students. I wanted to show it to you. So let's give me a minute. So are you seeing this? Yeah, I will add my camera so that you can see. So in the camera, in my phone's camera, it is not working. Tomorrow I will show you, but today we can show it by using this camera, right? Okay, let's give me a minute. Okay, so now can you see me? This is how a breadboard will look like, right? So this is how a breadboard will look like. So here these lines are connected. So this is the middle part of the breadboard, and I have the top part of the breadboard, right? So this top part, you can see that these horizontal lines are connected. So this is how a breadboard will look like. So this is how a breadboard will look like. So hope you see this, and these are very simple things you can understand. So this one, right? So what we have to consider in here, right? In here, what we have to consider is simple, right? Because we have to consider the color codes, right? So if you consider the color code, the red line, the positives are in red line, right? So on after the bulb is connected, the wire is blue line or blue or black lines. So this is how we can draw a schematic diagram, right? So this is called a schematic diagram. And on this one, the physical one, they didn't use the color code, right, in the picture. Right? So this is very simple. So hope you understand these things. If you don't understand, you can ask me questions, right? Okay. So next thing is I gave you another example to do. So how will you connect the circuit diagram by using a breadboard? Actually, how will you connect these things, right? So we can connect these things very easily, right? By using this software or this one, right? So I will show you how to connect by using this software also in our classes, right? So here we have a battery, right? So here we have a battery, and this battery, uh, the positive terminal, right? The positive terminal means the red line. The red line is connected to this breadboard, right? So that means entire top maximum line is positive. That means if the battery is 3.7 voltage, this entire line, this if I connect the wire from this one, that is all, that will also give me 3.7 voltage, right? So this is how we connect the battery. And also the negative terminal of the battery is connected to the other side, right? So that means we have a positive 3.7 voltage in each and every dotted on the top of the breadboard, and on the second layer we have negative terminal, which means we have zero voltages, right? So after we have connected that one, what will you do? we have connected the positive terminal at the 8th terminal, right? So we have to connect positive terminal to 8, 8th pin, right? So I take this one, right? So this means I take 3.5. So if in the software 5 voltage is not available, so that is why I took 3.7 voltage, right? So no matter, right? So I have 5 voltage from here, and I have connected this one to the 8 pin. So this is the chip, this is the IC. I connected this one, right? And also for the ground, you can see that fourth pin is connected to the ground. So I can get fourth pin, right? Fourth pin I can get from anywhere, anywhere on the second line, right? So I took from here because I used to say that we have to use only a separate portion of the breadboard. We can't use here and there. That is ugly, right? So that means we can't work several projects in a single breadboard, right? So we have to use only one portion of the breadboard. So you can see clearly how clean I have connected, right? So next thing is we have to take a fifth pin and connect it to a resistor, right? So we have to take the fifth pin and I can connect this in this breadboard pin. So you can see in this breadboard, these lines are connected. Each and every lines are connected, but this one and this one is not connected, right? So you know these things. So I have connected in this pin, right? After that, I select the pin here and I connect this one because we can't short circuit this resistor, right? So if we connect here and here, that means the resistor is connected to parallel, right? So we have to connect like this way. We have to connect this and this. So I have to connect this and this. After that, I select the line here. This is if we draw a bulb like this one, this way, this that means this is positive, right? So I have connected the positive positive terminal of the LED bulb, and then I ground it here. So how can we ground this one? So somewhere in this line, we can connect from here and then we can connect it to the ground. So this is how we can create an actual circuits from the diagram, right? So hope you understand these things. If you have any doubts, you can ask it to me. Do you have any doubts? Okay. So in this class, you can ask questions, right? So if you ask only questions, you can understand these things very well, right? Because it looks simple for you if you see this picture, right? But when you are working on these examples, you will face different problems, right? So how can I take the wires? How can I connect it to the terminals? And how the battery will be look like? So those kinds of things will be experienced by you if you work on these examples, right? So please try to work on the examples. And also, if you don't have the components with you, I have a software that can simulate the examples, right? So whatever we have learned in our uh, classes, you can practice by using the software. I will show it to you, right? Okay. So next thing we are going to learn is, so nowadays we are advancing, right? So we are going to learn transducers. Transducers means the components that can be connected to the controllers, right? Controllers means we saw that controllers can be Arduino, Raspberry Pi, PIC. Also the previous example we used an IC, right? So we use an IC. This one is also a controller. Okay. So in this controller, uh, whatever the components we connect it to the controllers, we call them transducers, right? So as an example, but with limited to power sources, right? So if power sources are not considered as transducers, right? So we have to be aware about, and we can categorize them into two, right? Transducers, we can categorize them into two. One are sensors, and another one is actuators, right? So sensors means they are sensing the physical properties, right? So as an example, they can sense the sound, right? They can sense the light intensity. They can sense the humidity. They can sense the, that means the water content, whatever the physical properties, right? That means we may feel that also, right? So if we are sitting on the hot environment, we can sense that hot, right? So same way, sensors also can sense that one, right? Sense those environmental factors, environmental properties. They can also sense them, and they, what they do is simple, right? So as we humans, how will we sense them? So as an example, if we have an ice cream, so how will we sense when we bring the ice cream near to our nose? Our nose is sensing, right? Our nose is sensing the smell, right? So then after, our nose is transferring it as an electrical signal, right? Then after, our nose is sending the electrical signal to our brain, right? Then after, the brain reacts. So this is a smell effect, or it's a bad smell. So likewise, our brain is processing. So similar to our brain, in electronics, we have controllers, right? The controllers are similar to our brain. So they process, right? So after we process, so if it is a good smelling, we might try to eat the ice cream, right? So the mind, our brain, is putting an order to eat the ice cream. So what will you do in order to eat the ice cream? You will try to so what will you do? You will try to bring your hand, right? So bring your hand near to your uh, mouth, right? So this is similar, right? So that way, in electronics also, the similar to nose, there are some kinds of sensors, right, which are sensing the environmental factors, environmental properties. Then they send the signal to the controllers. After that, the controllers are controlling the sensors as well as actuators, right? So actuators means, you can simply say that bulbs, motors. So that means output parts, right? Motors, bulbs, uh, buzzers, etc. Those kinds of things are called as actuators. That means actuator can be defined as a component that does an action, that a component that does an action that is obtained from the controller, right? So that can be defined as that one. So in sensor, we can categorize them into further two categories. That means digital sensor, analog sensors, right? So in digital sensor, that means after, also we have smelling sensors also. Huh? So we have smelling sensor. That thing will be discussed in our next slide. So we have lots of sensors, right? So sensors, what they do is they send electrical signal. If they send electrical signal only 0 voltage and 5 voltage, that is called as digital sensor. So that means we can only get two values, right? So that means we can only get, if the smell is available, we can get 5 voltage, right? If we don't have the smell, we can get 0 voltage. In between, we can't get, right? We can't get the levels of the smell or whatever the things, right? So that is called uh, digital sensor. We can get only either 0 voltage or 5 voltage, right? So on the other hand, we have analog sensors. Analog sensors means we can get whatever the value, either this one 0 voltage, or either 5 voltage, or either in between these voltages. So that is called analog sensors, right? So that means we can sense the level of the smell. Right? As an example, we can sense this smell is very low, this smell is medium level, this smell is very smell. So likewise, we can sense the smell in different levels. So that is called analog sensor, right? So I will show you the pictures so that way you can easily understand the sensors. And actuators, we have hydraulic, pneumatic, and electrical actuators, right? So we are not going to focus hydraulic, pneumatic actuators in this basic course because they are related to uh, highly machine environment, so that they are used in machineries, right? So in machineries, we will not going to look after those things, right? So we are going to learn is electrical actuators only in our course. So in electrical actuators, we can use relays, bulbs, motors, pumps, and uh, and also we can use the buzzers, right? So that we call piezoelectric buzzers, etc. Hydraulic means actuator. The actuator is actuated by a hydraulic force. That means we can use water or other liquid particle to push or operate the equipment, right? So whatever the medium we use, that is called as actuator, hydraulic or pneumatic or electrical, right? If we use water to push a rod, that is called as hydraulic actuator. Similar to that, we can use our air, right? In air also we can use as an actuating medium, right? So these are simple things I will show you. So sensors we have in robotics or in Arduino sensors, we call them. In robotics, we have lots of sensors, right? Sensors means, let's say, the equipment that is sensing the environmental properties, right? So we have sensors, one part search sensor, right? So that means we have a sensor. Uh, this sensor is used to sense a line. Okay, so if we have a line here like this, right? So this line is painted in black color. Okay, so if we place the sensor, right? So if we place the sensor, that means this is the face of the sensor. If we face this face on the line, the sensor will not give you the results, right? So not give you the electrical voltage, right? So if we place the sensor on this place, right? This is similar to as a camera, right? We can sense that them. If we place the sensor here, and the voltage will be obtained. So that means in here we can see that this one is emitting a signal, right? So after the signal is emitted, if we have an object here, after the signal, like after the radiation is touch the line, it will be reflected to this one. So this is called as a transmitter. This is called as a receiver, right? So we have two components inside the sensor. So after it is reflected, the device will be sensed, right? So if you take a sensor and look look at it, it will show you basically three components, right? It will show you three components. Three components mean we have positive terminal and negative terminal. As I told you earlier, in our phones, we have to power up the phone before we are before we operate, right? So similarly, sensors also have to be powered up, right? So we have to give power at VCC, right? We have VCC terminal right? That can be uh, written as VCC terminal. In that VCC terminal, we have to power up, right? We have to connect the positive terminal, and then there may be a GND written on it, right? So if the GND is written on it, we have to ground it, right? So in from a battery, we have to connect the positive terminal to VCC, and we have to connect the negative terminal of the battery to the ground of the sensor, right? So that way we have powered up the sensor. Okay. After we have powered up, we have to obtain the output signal. So that there can be written as out, or there can be written as V out, V out, or out, right? Or out, or even O is used, right? So that is how they use, right? So you can identify. So what is V out signal? Can anyone know what is the V out pin is for? So we have V out pin, right? So we have what we have to do is we have to connect the positive terminal at the VCC, negative terminal at the ground, and we have to obtain this signal, right? So this is the identifier identifying component, right? So as an example, if we place the sensor near the black line, it will show you zero voltage. The output voltage will be zero, right? If we face the sensor on other areas, it will the
Excuse me, sir.
yes,
Where will be displayed
sorry,
the V out?
yeah, V out will be displayed in the sensor module, right? So if you take from your Arduino box, you can take a sensor, and if you see it, and in the pins here, we can see those things, right? Right. So
Okay.
if we face the sensor at where else, so whatever the position, and then the signal will be not zero voltage, it will be 5 voltage, right? So this voltage signal, this is called as voltage signal. Okay, this voltage signal is used to detect the environmental properties, right? So this can be connected to our controllers, like as our brain, right? So this can be connected to the controllers, and then controllers will we can program, either program it or visually program it. Okay, so then after we can control the actuator. So this is how this is the basic of how the sensors will work, right? Because we basically whatever the sensor you take, it will have these three terminals. So don't confuse with these three terminals. What we have to do is we have to firstly turn on the sensor. We have to power up V positive to VCC, battery to ground, right? So then we have output voltage, and then we can connect it to our relay or our Arduino. So those things will be discussed later, right? So please understand these things. If you don't understand these things, you can ask me questions. I will also demonstrate these things to you so you can understand those things as well, right? So some sensors may have four values or four or five pins, right? So if you see this sensor has more than three pins. So it has five pins, right? So each and every we can simply we can't study each and every sensor, right? So there are millions of million sensors available in the world, right? Even they have tons of uh, brands in sensors, right? So what we have to do is, but if we are having a sensor, we have to write the model number of the sensor in our search box, right? Search box means we have to try it in our browser, right? Web browser, and then we can obtain the connection diagrams, and then we can easily connect it, right? So that way we can understand each and every sensor, right? So we have flame sensor, right? So flame sensor is used to detect the fire, right? So if there is any fire, the sensor will detect and give the electrical current, right? So next we have laser head sensor. So this sensor will send a laser signal to that one. If any object is cut down its laser spotlight, the sensor will detect the position, right? So at how many distance the object is detecting. So those kinds of things can be detected by this sensor. Okay. Next thing is we have clock module. Clock module, we can use this for calculating the time, right? Time dependent variable, right? So those things. Super regenerative module, we have temperature and humidity sensor, raindrop sensor, soil sensor. By using one of the sensor I showed here, you can create tons of projects. Okay. So as an example, if you select this sensor and go for a project, you can work on several projects, right? Such as I can show you too. We can create a line path, right? So we can get a cello tape and then we can draw a line on the floor like this, right? So then after you can place a sensor here, right? So if you place the sensor on the light, you will be you will activate an alarm. A simple project, right? So if the sensor is placed on the black spot, right, black spot, the alarm will be turned on, right? So that after by day developing it, we can design a line following robot, right? So that we call as like a robo car can be created. So this car can be following will be following its path, right? Whatever we draw the path, the car will be following, right? So those kinds of project we will learn in our future classes. Okay. Yes, of course, we can use soil sensors. Soil sensors mean the meaning of the soil sensor is we insert a sensor on a soil sample, right? In your home garden, you can buy this sensor. Basically, this sensor will be very much low price, around 300. You can buy it, right? So you can buy the sensor and you can attach the sensor uh, to your plant, right? So plant water, so sorry, the plant jar, you can insert the sensor. Okay. So after you have inserted the sensor will sense the uh, water amount, right? Sensor will sense the humidity amount. That means if the water is present, the sensor will send a value to the controller, right? So on that way, we can irrigate our plants, right? So that means we can create smart home gardening systems, right? So that means if the water inside the plant is dried out, if the soil is dried out, the water can be automatically irrigated, right? So that way we don't have to uh, watering each and every day, right? We only connect this one and then we can implement these things, right? So another thing, in sensors we have lots of sensors, right? Ultrasonic module sensor means it detects any object inside its path, right? So uh, if we are having any object, right, so that means so let's say as an example, basically currently I don't have the sensor. So let's assume that this is the sensor. So if an object is obtained here, the sensor will alarm. So that means the sensor will be activated, right? So if there is no object present in the line of the sensor, it will not detect, right? So can you think any of the projects by using that sensor? Can you think any?
Robo
So what kind of robot can you think?
car.
Yeah, in a car, right? So let's say this is a car. So as an example, okay. So this is a car. We can install the sensor in the car, right? So after the sensor is installed, the if the car is moving towards a wall, right? So towards a wall, the car is moving, right? So touches before it touches the wall, the car can be turned left or right side, right? So that way we can protect the car from touching the wall, right? Similarly, we can think lot of different kinds of projects, right? So that is how we can use these sensors, right? So next thing is human body sensor. Human body sensors mean this is also called as
Yeah.
PIR sensors, right? Yeah.
Excuse me, sir. What about domestic security sensors?
Sorry, I didn't get you. Can you ask me again?
Sir, what about domestic security sensors?
Yeah, domestic security sensors means the sensors can be used to detect human presence. So these can also be called as one of the domestic security sensor, right? So this is called as PIR sensors, right? PIR sensor means if this we have placed a sensor here, right? So as an example, we place a sensor. If the human motion is present, right? Human is moving on the area of the sensor will detect, right? So by using this sensor, we can protect our homes, right? So that is called as uh, home security systems, right? So in our home we can install this sensor, and if any thief or if any unauthorized person is appealing on the face of the sensor will be sending the signal to the controller. After it reaches the signal to the controller, we can program it whatever we want, right? We can program it as it should alarm the system. We can program it as it should turn on the lights, turn on the our night lights, right? So those kinds of things can be even uh, for my previous classes students. What they did was they did the internet based system, right? So if the person is appealing here, it should send a message to the person, right? So it should send the message to the user. That means the person is passing the sensor nearby. So that means we can integrate the ideas for uh, doing more kinds of projects, right? So next thing is tilting sensor. We have tilt sensor in our smartphones, right? So tilting sensor mean if we, let's say we have a sensor, the sensor is tilted, right? So tilting means we can do like this, right? So if we are tilting this, we can we can get a signal from that one. So that means if it is in the horizontal plane, horizontally, if it is horizontally placed, there will be no signals, right? So if it is tilted, there will be a signal, right? So that is called a tilt sensor. And photosensitive sensor means only this is the photosensitive sensor, okay? This one is called as module, right? So both this is called, this also can be used as photosensitive sensor, right? So what will happen is uh, if it is receiving, right, this phase is receiving any light intensive items, the sensor will detect, right? If the environment is dark or we place the sensor in night, there will be no signals, right? So can you think about any ideas by using this sensor? Can you? Can anyone tell it to me? What project can you make by using this sensor?
For home,
Yeah, for home, what kind of project can you make? So basically we have to say,
when we go out,
oh, yeah.
we forgot to switch on the light, the outing light.
So basically what we have to do is if the light is present, so we have to change a little bit, right? So what we have to do is if the sun is gone, right? If the sun is gone, that will be dark, right? So that means if it is dark, we have to automate, we can set it as automatically we can turn on the lights, right? That means in your home, if the sun is gone, you can turn on the light automatically by using the sensor. So that is why we use the sensor, right? So again, don't work on the AC current, okay? Just work on these currents, right? So as an example, if you want to demonstrate it to me, you can work on by using this sensor. You can obtain a sensor, okay? You can obtain a sensor. You can connect it in the breadboard, and you can use relays or Arduino. Arduino we will learn in our other lectures, right? In future lectures we will learn Arduino. So what you can do is you can obtain sensors and you can connect these things and you can turn it on your LED bulbs, right? So this is called as LED bulb, right? So I can show it to you. So you know that what is LED, right? So basically I'm out of component due to the pandemic. I sold all the components. So this is called this small light is called as a LED bulb, right? So these LED bulbs can be blinked, right, by using the sensors. So all the things, right? Smoke sensor means, next thing, smoke sensor means we can detect smoke, right? So if a person is smoke, we can detect him, right? So next thing, infrared barrier sensor, right? So infrared barrier sensor means these sensors same as these sensors, right? So these sensors are similar to the previous sensors. So wait a minute. The sensors are similar to this sensor, path search sensor, right? Whatever the object is near, the sensors will detect, right? So if you place a sensor here and then there is an object, it will detect, right? So but infrared barrier sensor means sometimes these sensors may not detect our hand, right? So it may pass through the signals, right? So those things are the difference between this and that, right? So it will only detect metal components, right? So that is called the infrared barrier sensor. Next thing is vibration sensors. Vibration sensors mean if there is any vibration, it will detect, right? So sound sensor means also the sound is present, the sensor will be detected, right? So you can see that there are most preferably 3 pins, right? So what are the 3 pins? Can you explain? What are the 3 pins we have? Can anyone tell it to me?
Positive,
Yeah.
negative,
Next one is
Ground.
no,
Ground.
no. That is not ground because he told me that positive and negative. Negative means ground, right? Negative means
Up.
that is the ground. Next pin is out pin, right? Sensor is an input device, okay? Sensor is an input device. So this is a sensor example. So this is a controller, right? So this is an actuator. Let's say an example. This is an input device, sensor, right? It inputs the signal to the controller. That is why this is basically we controllers are the central parts, right? So sensors are input devices, right? Actuators are output devices. So because we take output, right? We take outputs from the controls. So that is why we call them as output devices. But the sensor, for if it is a sensor based, right? Sensor is sending the signal to the controller, right? So that is why we have sensors out. So that is we call as out signal, right? So don't confuse on these things, right? So it sensor is sending outwards, right? So if it is sensor based, then that is the pin is dependent, right? So hope you understood this. Next thing we are going to learn is actuators, right? So we saw that there are three types of actuators: pneumatic control valve, pneumatic control actuators, electric control actuators, hydraulic control actuators, right? So these are some of the examples. We are not going to learn these things in our classes because these are heavy machineries used in higher engineering applications, right? So what we will learn is very basic components, right? So so these are the components that we are going to learn in our robotics class, right? So these are the actuators, right? So we can get output from it, right? So LED bulb is like it will act as an indicator, right? So we can obtain indication purposes. We can use this, right? So next thing is this is called as piezoelectric buzzers, right? So simply we can call them as buzzers, right? So buzzer, we have two terminals, right? One is positive and other one is negative. A term is used to define the electronic components is polarized, right? You can type it here. A term polarity, right? Or polarized, a polarized, right? A term can be used, right? Polarity means the buzzer will work only if we connect the positive terminal to the positive, negative terminal to the negative of the battery, right? It will only work if it is polarized. We have to only connect the positive to the positive, negative to the negative. If we connect on the other way around, it will not work, right? So that is called as polarity. If the polarized components, we are using polarized components, we have to be aware about its terminals, right? So in this terminal, that can be written as positive on the side, right? So we have to be aware about that one, right? So if it is positive, we have to give the positive to positive, negative to negative, right? So if it is not polarized, we can connect whatever we want, right? In motors also, so in motors, right, it has a positive terminal and it has a negative terminal, right? If we connect a battery like this, right, so we obtain a battery positive terminal, and then we take negative terminal and connect the motor to the negative terminal, right? If we connect like this, motor will turn clockwise, motor will rotate clockwise, right? If we change the battery, so that means if we connect the motor on the other way around, that means we are obtaining on the battery's negative terminal to positive, positive terminal to the negative, the motor, right? Not all the motors. Some motors which are non-polarized will turn on this direction, which means on the other direction, anti-clockwise direction, the motor will be rotating, right? So that is the thing we have to be aware about. But if the motor is polarized, it will not work. If we change the connection terminal, it will not work, right? So that thing we have to consider. And then we have a digital display, right? This is called as display. We can use this in our Arduino also, right? So these are some of the motors that are available in robotics, right? So we can select proper motors according to our design things. So uh, please be aware about that in your Arduino box, right? So you can open up your Arduino box and you can see the components, right? So it may have some sensors, it may have actuators, it may have some controllers, right? So these components you can identify and categorize them, right? So you can work according to what you have, right? You can't say that like I don't have that component, I can't work on that particular project. You can't say like that, right? So whatever the component you have, you can think about what projects can I make, and then you can make it, right? So as an example, if you have if you, at the least case, if you have an LED bulb and then and a switch, you can create a circuit, right? If you have this piezoelectric buzzer and IR sensor, you can make another circuit. If you have this circuit and another sensor, you can make another circuit. Likewise, you can create several kinds of projects, right? So uh, so don't use Arduino, right? So this is Arduino. We will learn Arduino in a little bit later. Don't use Arduino, because if you connect the Arduino to your computer and you connect the battery on the same time, the Arduino will be broken up. So that means the Arduino will be defected, right? So after you can work on Arduino, but until that you can work on these components, right? Inside your Arduino box, you can work on these components, right? So these are DC motors, right? On the top we have DC motors, right? So these are brushless DC motors. These two are brushless DC motors. These are brush normal DC motors, right? This one is a geared motor, right? So this one has gears inside, so that is why it is big, somewhat uh, somewhat larger. So another thing are these are servo motors, right? So these lines are servo motors. Servo motors means there is a difference between DC motor and servo motor, right? So I have a servo motor here, right? I have a servo motor here. So this is a servo motor, right? So what the servo motor can do is it can rotate only a portion, right? It can rotate only this one, right? So basically this motor can rotate uh, full, okay, clockwise, but some motors will rotate only a portion, only 180 degrees, right? But they can't rotate further on 180 degrees, right? They can only go for half a circle, right? Half a rotation. So that is called servo motor. So why we use servo motors is simple, because we use servo motors not for uh, rotating running purposes. That means we can use let me show you. So I have a chassis board here, so we can connect the chassis board. So what I have a DC motor here. So this you know that this is a DC motor, right? Inside it has some gear components, some plastic gears it has, right? So after we have uh, connect this DC motor, we can create a car like this. But by using this motor, we can't create cars. Right? What we can do is we can create positional accurate components. That means we can create robot arms, right? So that means let's say I have a hand here, right? So my hand, what can I do with my hand? I can rotate this one. So how many angles I can rotate? Only 100, maximum of 180 degrees, right? So until that I can rotate. So that way we can design. So as a simple for you to understand, you can even select the plastic, right? So you can even select a plastic, or you can use a ice cream stick, right? So you can use even an ice cream stick, and you can stick this, right? You can stick this, and what can you do? You can make a robo arm, right? So you can make a robotic arm by using these servo motors. So by so these are 9G servo motors, right? So we can lift higher weight, right? So we can lift higher uh, what do you call higher weight components. We can lift it. If we want to lift higher components, we have to go for the servo motor like this, shown in the this one, right? So this black color and this one, we have to use this motor. These motors are used for carrying higher capacity of loads, right? So if we are using small loads, we have to use for this one, right? So these are also servo motors, right? So different, according to the different weight it can carry, the motors are different. Okay, so these are uh, different devices. This is a DC motor connected to the tire. This is also a DC motor. This can be connected to a wheel, right? So that means we have these tires, right? So we have these tires. These tires can be connected. The whole can be connected to this one, right? So this one we can connect this one, and then if we power up, we can rotate this one. Okay, so those are the things. So next we have another exercise. So can you work on this exercise? How can you connect this, right? So we have a battery, right? So we have a battery here, and it is connected to this breadboard to make it as positive each and every line, this line, right? That means this line is all are positive, right? So what he did is uh, he took a positive terminal, right? We can attach without jumper cables, right? So this is called a jumper cable. We don't have to use, because we can get off directly by using resistors, right? So we can get directly, and then we can connect. Then after we have to connect an LED bulb by using this one. So because these lines are connected, you know that these lines are connected. So this is connected. So here this is connected, right? So we can obtain from a bulb, and then we ground it, right? So this is how we connect. So please connect this circuit on your components. So these things you can connect them and see whether the current is working or not. So the bulb, so before you connect an LED, you have to put the resistor, right? So if you connect the LED bulb directly to the battery, the bulb will be defected, right? So then after you can't use your bulb, right? So what you have to do is, if you have a 9-volt battery, you have to put a resistor, right? Let's say it's a 10 kilo ohm resistor. Inside the Arduino box, you have this resistor, right? So you have to have a you have to obtain a jumper cable, and you have to connect here, and then you have to connect the resistor, and then after you have to connect an LED bulb likewise, right? So what you have to do is, you have to turn on your LED bulb, right? This is your first task, right? So exercise 1, you have to do this, right? You have to do this and take a photograph and send it to me, right? So not in the group, but you can even you can put it on the group, but I will say that if it is annoying for other people, you can send it to privately to me, right? So you can connect this, but what you have to do is, you have to connect by using minimum components, right? You can't use a lot of jumper cables and connect this, right? So you have to use minimum components while you are connecting. And also you have to connect one portion of the breadboard, not utilize all the breadboards, right? So not use all the breadboards. You have to utilize your breadboard for only one portion, and you have to connect this and show it to me. So those who don't have a breadboard can connect without breadboards. That's very simple, because why we use breadboard is connecting the terminals, right? So if you don't have breadboards, you can obtain jumper cables, you can connect male. You, on that particular case, you have to have male to female cables, right? So female to female, male to female, those kinds of different cables you have to have. So then only you can connect those components, right? So right, this one is up to you. If you have any doubt, you can ask it to me, right? After that, I have another exercise. So then after you have connected this one, and take a photograph of this one, after you have successfully completed this one, you can put a switch, right? You can insert a button in between the resistor and then LED bulb, right? In between the resistor, sorry, so this one, so this is the battery, so this is the resistor, and then after you can connect it to a switch, right? So then after you can connect it to a LED bulb, right? So then after you can connect it into a LED bulb. So that way, if you turn on the switch, the bulb will be turned on. If you turn off the switch, the bulb will be turned off, right? So likewise, you can create several kinds of circuits. Whatever you do, you just take a photograph and then send it to me, okay? That is very important. You have to work, right? So then only you can understand these things, and basically the course is for fully application based, right? So in future we will learn. We are dealing with the real components, right? So you have to be working, right? And also you can expand this exercise, right? You can expand by putting different switches, right? You can put two switches, right? So you can connect seriously or parallelly. So what you have to do is, firstly you have to draw a schematic diagram in your exercise book, right? In your exercise book, so you have to connect a series of switches, and then you can connect a bulb with the battery, and then you can see how it will work, right? So then after, what you have to do is, you have to connect a battery from one switch, and then you can connect an LED bulb, and then you can connect it to the ground, right? So then you have to obtain another switch, and you have to place it another LED bulb, which means another color LED bulb, right? So then you can connect it to the ground, right? So likewise, you can create several projects, right? So what will happen is simple. If we turn on this switch, the red LED will be turned on. If we if we tap this switch, the blue LED will be turned on. So likewise, you can create these things, right? So please work on this example and do these things, right? So students, do you have any problems or doubts regarding this? Please ask it to me. So then we can move on, right? So connect this circuit, okay? So next thing is, we have another exercise. Design a car reverse taking safety system. So this is a case we are going to design, right? Design a car reverse taking safety system. So that means, so I will explain the phenomena, and then you can tell it to me, okay? So this is how the system will be look like, right? So what we will have is, we have a car here, right? So in a car, we have attached a circuit or a system, right? So that system you have to design, not the car, okay? You don't have to design a car. You only have to do is design a circuit system, right? So in this system is attached on the right? This system is attached on the car, on the back of the car, right? So the driver is here, right? So the driver is here. It is attached on the back of the car. So there is a wall here, right? So if the car is trying to uh, touch the wall, before it touches the wall, there should be an alarm, right? There should be an alarm. The system should awake an alarm so that the user or the driver will be aware about the car's reverse, right? So if any components, if any object is behind the car, so then the driver will be aware about, oh, there is an object, so I have to be aware about that. So that manner the driver can be aware about that, right? So can you design a circuit, right? Can you draw so on, while you are designing, what you have to do is simple, right? You have to think a simplified circuit and state assumptions you made while designing the system, right? You have to state assumptions. That means you can assume that the car reverse taking distance can be limited to only 10 millimeters. 10 millimeters means 1 centimeter, right? So that means you can assume that whatever you want, you can assume, right? So some people in previous class, in Tamil medium classes, my students were able to do by using ultrasonic sensors, right? So that one is a little bit complicated. By using, we have to use Arduino. So before we didn't learn Arduino, right? So you can use IR sensors, right? IR sensors can be used for this project, this exercise. You can design, right? So you can assume that the sensors limited the limitations are for limited for even 5 centimeters. You can assume those things, right? So then after, what you have to do is you have to draw a schematic diagram. Schematic diagram means, you know, that you have to draw a circuit diagram like connecting batteries and how will you connect, right? So those things you have to draw, right? After you have drawn the schematic diagram, you have to draw you have to practically make the circuit. So this is a task for you, right? You can simply uh, design a task, and I will upload what my previous student did in previous classes on the group. If I have the video with me, if the videos are available, I will send it to the group. Okay, so uh, you can work on this project, right? So I will give you a hint, right? So I will give you a hint about, you can use these components. So only you have to do is you have to connect and work on it, right? So you can have an IR sensor, right? So this is called an IR sensor, right? If an object is near the sensor will be detected, right? So it will send a signal to the controller. Here we are using a controller, relay controller. So relay is used as a controller, right? So we don't use Arduino here because we didn't learn Arduino. So after we learned Arduino, we will do those things in later, right? So now we are going to connect these components and make a simplified circuit, right? So I am giving you some of the examples because the course is limited for 2 months. I am giving you some examples, right? So, but you have to work more. You have to, in your free times, rather than wasting your time in your smartphones or in your computer or in your TV, you can think about the simplified circuits, right? What you can make, right? As I told you earlier, you can turn on the bulbs if it is at night time, and then you can simplify. You can simply think about what can you make that will make you a scientist. That means you make you an innovator, right? If you can think and innovate these things, and you can contribute to our country, right? That means you can innovate new products, If you are interested in from your grade 6 or grade 7, you can make more things after you have graduated, or after you have come to AL. You can make different kinds of innovations, right? Innovations means, that means you have to increase the people's prosperity, right? Rather than wasting or destroying them, you have to think creatively and make them as prosperity, right? So we have to think about the different systems we can create, that we have to focus on inventions, right? So if you are an inventor, so you can create some inventions, and you can show the inventions to the Sri Lankan Invention Council, and then you can get funded funds, right? So you can get funds for your projects, and then you can expose for more even you can go for foreign countries to demonstrate your inventions, right? So you can get awards, you can get rewards, all the things you can get, right? So only if you think and work on these kinds of innovations, you can uh, you can be identified more, right? So what you have to do is you just have to think and work and learn, right? So think about this circuit. So next thing is buzzers, right? So the buzzers can be used for alarming, right? So rather than alarming, you can, if you don't have these buzzers, you can use LED bulbs, right? By using LED bulb, after if object is near the bulb, the red light can be turned on. So you can put an red LED bulb, red color LED bulb, you can put it, right? So different colors according to the different distances, we can put different colors. So that is little bit complicated, right? So that will be learned in later. So you can simply put one bulb, and if the sensor detects, you can design the circuit, right? Of course you have to have some jumper cables, and you have to have, you don't have to have this one, right? Breadboard is not necessary, right? If you have breadboard, you can design it. If you don't have it, you can use this by using only a jumper cables, right? So you have to have a battery also. uh, so that's all about the hints. It's up to you now. You have to work. So students, do you have any problems regarding or questions regarding this so far? You can ask it to me. So
Yeah.
tomorrow you will be doing this exercise 1 and 2, right? This one, and then second exercise is you have to put a switch and then show it to me, and then this one, right? Right. So how many students are there without having the components? Can I know? Okay, one person uh, doesn't doesn't have any component. So for you, in tomorrow's class, I will let you know, right, how we can collaborate with these things, right? So tomorrow class, that will be uh, very much related to software side, right? Software side means tomorrow we will learn how to arrange them virtually, right? So that will be very useful for the students who are not having the components with them, right? So but I highly recommend that you to buy some components, right? If you buy those components, you can get more knowledge, right? So when you really practically work on those components, you will have definitely have some problems, right? So some, the wires can be broken, and the LED bulbs will be defected. So those kinds of things you can practice and test them, right? So those are the experience that we call them. So if you can, you buy it. If you can't buy it, it's no problem. just attend the classes and I will show you how to work on softwares, right? So tomorrow we will have the classes at 8 p.m. right? So I will send you the link. So if you have any doubts, you can clarify it to me. Right, since you don't have any doubts, we will wind up the class. Thank you for attending the class, and thank you for the person who have paid all the payments for the first month, right? So for the next month, I think you have to pay the for the second month fee also, right? After the second month is started, you can pay, right?